Okay, so here we are on number 29. We are graphing. It's multiple choice. So we're going to do this one by calculator. When you graph trig functions, you're going to want to make sure that your mode's on radians and it's also on function. Then go to y is equal to, put in your function. This one is sine of 1/2 x. And you can choose a window here. Zoom standard is good. There's several windows that are good. But I tried Zoom standard and the graph was too crunched together, so I put less numbers on the x and y axis. I went from -6 to 6 on the x axis as well as the y axis. Okay, if you graph, this is what you get. You're going to want to notice some distinguishing characteristics so that you can choose between the choices you've been given. This one goes through the origin, and on the right side of the y-axis it begins to increase. At 3 it has a y value of 1, so let's see what our choices are. Okay, we actually only have 2 that go through the origin. This one goes through the origin and increases on the right, begins to increase on the right side of the y-axis, so does this one. But at 3, this one claims there's an x-intercept, whereas this one at 3 is up at a value of y is equal to 1, which is what the calculator showed. So this one is choice D. Okay, it's 29. 30. Also multiple choice. I'm going to get rid of this graph. Type in 2 cosine x plus pi divided by 2. Can change the window if we need to, but this looks pretty clear. This one also goes through the origin, and on the right side of the y-axis begins to decrease right away. And right about 1.5, it's down at approximately -2. Let's see what our choices are, because we might not need to think about it further than that. Okay, so goes through origin. This goes through the origin, so does this. This one doesn't. This one doesn't. So this one begins to decrease on the right side of the y-axis, like our graph in the calculator, whereas this one increases. So choice A is like the graph that we had here. Goes to the origin, begins to decrease, like that one. So choice A. 31. We are doing by hand. Let's make sure that I have this lined up. And for problem number 31, let me get that copied. It is y is equal to 2 cotan of 3x minus pi. Okay, first thing that you're going to want to do so that you can identify the phase shift, which affects other things, is to factor out this b value, which is the coefficient of x. Okay, 3 times x is 3x. Now you want to know what to multiply 3 by back here to get negative pi. That would be negative pi over 3. 3 times pi over 3, these would cancel, leaving you with the negative pi you had. Okay, so now it's factored, and now I can see the real phase shift rather than thinking it's negative pi. Okay, you are asked for the amp, which has to do with the A value. This is your A value, this is your B value. So the amp is absolute value of whatever the A value is, so it's 2. Next thing you're asked for is the B value, which is this coefficient of x. Then you are asked for the period, which is one thing that the B value is used for. The parent period on tan and cotan is 1 pi, and then it is altered by whatever the B value is. So the period for this graph is pi over 3. Then you are also asked for the jump. The jump is how far you're going to slide horizontally before you make each move having to do with the pattern for this graph. So we have a distance of pi over 3, and within that pi over 3 we need to make these moves. Asymptote, up, middle, down. That's the pattern for cotan. Okay, so the jump, since we need to do 4 things within this distance, that is why we divide it by 4. Okay, when you're dividing a fraction by a number, it's the same thing as multiplying by the reciprocal. So this ends up being pi over 12. That's how far we're going to slide horizontally, right or left, before making any of the moves suggested by this pattern. Okay, so that is the jump. The phase shift can be found by looking inside the parenthesis, the value that's with the x, and switching the sign on that number. So positive pi over 3 is our phase shift. So compared to the parent graph, which wouldn't have a phase shift, this graph is going to shift over pi over 3 to the right, positive pi over 3. But that'll all happen by way of the pattern. The vertical shift, if there was one, would be right out here, and there isn't one. So just none. Okay, then we want to start graphing, but we need to know where to start the graph. That's called the starting point or starting position. In this case, it's not going to be a point, so I'll call it the position. Okay, that has to do with this phase shift. You can let the x value, you can actually use anything as the starting point, but a calculation has to take place so that you get the y value correct. The reason I like the phase shift is because it is the value that when you plug it right in here, you get a 0, and that's easy to calculate at. So let's do that to get this y partner back here. So when you plug in pi over 3, and then you subtract pi over 3, it's 0. 0 times 3 is still 0, so you're going to do the cotan of 0, then multiply by that 2 that's there. So since we don't, if you want to put this in the calculator and we don't have a cotan key, you can use the equivalent of cotan, which is reciprocal of tan. That's how you write a reciprocal, and then you'll be evaluating the tan at 0. That you can put in the calculator because you actually have a tan key. Okay, so it's 1 divided by tan at 0 degrees. It quits on us, which means that it is undefined. And in terms of graphing, that means it's an asymptote whenever you get an undefined value. And that makes sense that we're getting that as our start point, because the very first letter signifies that there should be an asymptote as the first move. So that makes sense that this start point is at an asymptote. So now we begin laying out our x and our y axis. Our jump is pi over 12. Our starting point is pi over 3. You're going to want to make these compatible. In other words, same denominator. So to turn this into 12, you'd have to multiply this by 4 as well as this. That would give you 4 pi over 12 with an asymptote as its partner. Okay, so we're going to be counting in 12ths. 1 12, 2 12, 3 12, 4 12, 5 12, 6 12, 7 12, 8 12, 9 12, 10 12. I'll label them every couple. So this is 2 12ths, this is 4 12ths, this is 6 12ths, this is 8 12ths, and this is 10 12ths. And you can get some numbers going on the negative side as well, but this should be sufficient. Okay, so the starting point is at 4 12ths, and we should have an asymptote there. So this will be my asymptote. Then the next thing we're supposed to do according to this pattern is plot a point. Whenever it says upper, middle, or downward, those are points. When it has an A, you're doing an asymptote. So we need to know where the upper, middle, and downward shelf is. Now, the middle shelf, since there was no vertical shift, no vertical shift, that means that the x-axis is the middle. And knowing where the middle is helps you get the upper and the downward levels. And that's controlled by the amp. So from the middle, we're going to amp up 2. 1, 2, and that will be our uppermost shelf. So that's as high as we'll go when we're plotting points, and then amp 2 down from the middle. And we're at -2, and that'll be our lowest level at which we plot points. Okay, now we can continue using the pattern. We've already done this first position, the asymptote at 4/12. Now we're going to always use your jump every time you get ready to do another move within this pattern. So jump pi over 12. Pattern says that you should plot a point at the uppermost level. Slide pi over 12 again, and then you're going to be plotting a point at the middle level. Slide pi over 12 again, and you're plotting a point at the lowest level. You ran out of letters, come back to the front. Slide pi over 12, draw another asymptote. Okay, note being familiar with the cotan shape. This is the wave, the sort of waves that you have for tan and cotan. They just go in different directions. And then you might want to do either another wave this way or this way. Notice that the spacing between the asymptotes is the period, which is pi over 3 or 4 pi over 12. This is 1/4, 2. This is actually 1/12, 2/12, 3/12, 4/12. So by the time you drop your next asymptote, you're also going to want to move 4/12. So 1/12, 2/12, 3/12, 4/12. So this y-axis is actually the next asymptote as we go to the left. Notice that right in the middle is that turning point. To the left of that turning point is an upper point, and to the right of that middle point is a downward point. So you can just mimic this wave. Okay, this would be the middle, the turning point. To the left of the turning point, you have a point at the uppermost level, and to the right of the middle point, you have a point at the lowest level. So you can give one more wave, and that should be sufficient. Okay, that completes the review for Chapter 6. Good luck studying.